Okay, in this video, I'm going to demonstrate another option that you can utilize to carry out ARIMA modeling using SPSS. In the previous video, we were using data from Chapter 18 of Tabachnik and Fidel's time series analysis, it's actually an online or a PDF version or coming from this book right here. So Chapter 18 is not actually incorporated into the book in the hard copy, but it's rather it's incorporated as sort of an add-on or a add-on PDF. So I'm just going to kind of scroll up and show you what the chapter looks like. So what we did with our previous videos, we had time series variable computer quality measured over a period of 20 weeks. And we went through a series of processes where we determined whether or not the series on our quality variable or the time series on our quality variable was stationary. And then we determined that we would need first order differencing for this variable in our ARIMA model. So, and then following that, we examined the autocorrelation and partial autocorrelation functions to identify the autoregressive and moving average components. The first phase is identification. The next phase is estimation of your ARIMA model, and we utilized syntax in SPSS in order to test a couple of models out. So we tested one model, which was a 0-1-1 model, where 0 would represent an autoregressive component of 0. The first one is for the differencing that we had to use. So we used first order differencing for our quality variable, and then we also incorporated a moving average component, which was 1. So that was our first model, and in that model we also we estimated a constant, so that was our first model. The second model I walked you through was one where we had a 1-1-0 model, and we were not estimating a constant. So this is basically an AR1 process with first order differencing on the quality variable. And then I also kind of mentioned that when you're running your ARIMA models, you have to that second term is referring to the differencing for your variable. And so first order differencing just basically means that we're trying to kind of control for or remove a linear trend over time, so that's why we have a 1 right there. If we were trying to remove a quadratic trend to achieve stationarity, we would be using a second order differencing. But also we have to think about how we want to treat our difference variables. Do we want to leave them in their original units of measurement, or do we want to transform them? And sometimes you might feel the need to log transform the variable. And so to do this using the syntax, we would use the ln subcommand, and in addition to the other syntax. So that's how we were doing that. So this is a long way around to say that there is kind of an easier way of doing this, perhaps, and that is if you have the forecasting add-on that can be purchased from IBM SPSS. Basically, the add-on essentially provides sort of a menu-driven system, so where you wouldn't need to utilize the syntax, and it does provide some bells and whistles that can make life a little bit easier for you if you're carrying out ARIMA modeling. So I'll kind of go over a couple of those examples with you. Probably one of the more frustrating aspects of IBM SPSS is that if you want bells and whistles, you have to pay for it. And so this is kind of this is a forecasting add-in or add-on, and you can see that this can be kind of expensive. If you're a student, one of the nice things is that if you go to studentdiscounts.com, this is where I send my students. And if you want to purchase a premium grad pack, then one of the nice things is that it does actually incorporate the forecasting module in here. So there's an example right there. So you can actually get that. If you get the base version or the standard version, then you won't get it. So you have to get a premium version. Also, just kind of FYI, you actually have different licenses. So there's there's a 6-month license or a 12-month license. If you get the 12-month, it's considerably cheaper than if you get the 2-year license. And then obviously a 6-month would be probably a little bit cheaper than that. But at any rate, so let's take a look at running those two models that we previously ran using syntax. So the module, this is essentially a grad pack version of the program. And so what I'm going to do is I'm going to go to Analyze, go down to Forecasting, and you'll see that we have a little box right here that says Create Traditional Models. So if you don't have the add-on, you're not going to have this option. But click on that, and essentially we're going to move our quality variable over to the dependent box. Now I've already gone through the process of sort of identifying the ARIMA processes that I want to test or to estimate. So we're just going to stick with the examples that were provided in the Tabachnik and Fidel chapter 18. And so we move our variable over to the dependent variable box. You'll see method down here. Now the starting point right here, it says expert modeler, and I'll be honest, one of the kind of cool things is that because ARIMA modeling involves so much trial and error, this can be a useful approach if you don't really have much experience with this kind of modeling and you want to kind of identify a best fitting model or a good fitting model relative to other possible models. Then this might be a way to go. If you stick with the expert modeler and you want to sort of identify an ARIMA model that might do the trick in terms of capturing the variation on our quality variable, you can just click on Criteria, ARIMA Models, and then click on Continue. And then when you click on, under Statistics, typically I ask for parameter estimates, and I'll ask for this right here, leaving these other options where they are. So another option too is under plots. If you'll click on fit values, what it'll do is it'll plot the original series on your variable, and then the fitted values based on the ARIMA model that is generated. So if I click on OK, you'll notice that up here for the time series modeler using our expert modeler, you have ARIMA 010. So that's kind of the process that the program sort of decided on. You'll see that we have sort of a stationary R-square value, and so forth. We have various model fit statistics down here that can be consulted. And then this is sort of a plot based on the ARIMA model with just first differencing. This is a plot of in the red line, this is the observed values on the quality variable over the 20-week period. And then we have, based on the first differences, the blue line. And so you can see that the lines don't really correspond all that well to each other. You'll notice too that the blue line doesn't start at the first week because it's involving differencing. So it's essentially, the second week observation is essentially computed by taking the difference between weeks 1 and 2. So there you go. So that was just sort of a brief aside, but if you want to if you've gone through the process of considering possible models and you don't want to use the expert modeler, then what you can do is we'll click on this little button right here, go to ARIMA, and under criteria, now we lay out our different components. So you see we've got autoregressive difference and moving average. So this, these boxes right here are essentially going to correspond to, the PDQ processes that we've kind of discussed in the previous videos. So you'll also see that we have a box for non-seasonal and seasonal. We're not really focusing in on the issue of seasonality in this data set. It's a fairly simple data set. We don't have any kind of seasonal components, so we're not focusing here. And to get this box to even highlight, you've got to essentially identify, create a new variable for your data set that captures possible seasonal components. So that's why this box is not even highlighted here. So the first model that we're going to go with is the one, the 0, 1, 1, where basically we have a moving average, one process, and first differencing on our quality variable. So for this, the autoregressive will leave as 0. The difference, we're going to click here and we'll type 1 and enter. The moving average, we'll type 1 and enter here. Now you'll notice down here it says transformation. So how do you want to deal with this particular, the difference variable? And so it's the default is none, and this is really probably what we're going to stick with. There are a couple of other options, which includes taking the square root of the difference variable or the natural log, which I showed you how to get the natural log of the difference variable when modeling using ARIMA modeling using SPSS syntax. You'll notice another component down here. It says include constant in model. So this is, depending on how you want to treat the constant, then the default is to include the constant within the model. So we'll, in their demonstration in chapter 18 of the Defactioning book, they included a constant. So we'll do this and go with that process. So now under statistics, we'll leave pretty much everything the way that we had previously, and under plots, we'll leave everything as we had as well. If you wanted to actually save the residuals for the diagnostic phase, you can click under save and click on noise residuals, and that will generate the residuals. So as I kind of was reviewed in the previous video, where the diagnosis phase really involves looking at determining whether there are any remaining autoregressive or moving average components with the residuals using the ACFs and the PACFs. Then you can generate residuals using the save option right here, and then generate those plots. So that's how you can do it. So I'll just go ahead and click on this just to show you what will come out in your data set. If you want the predicted values, you can certainly click here, and there's some confidence limits as well. But we're just going to stick with the residuals and run our basic model. So I'm going to click on OK. And so now you can see we've got the ARIMA model 011 as we've just specified. You'll notice that when we scroll down, you get model statistics. So this is the fit statistics. Really, for this, we're kind of looking for a non-significance for this particular test right here, and so that's actually a good thing. And then the normalized BIC can be utilized for making comparisons between different kinds of models. You'll notice that in terms of the basic model information, you'll see it says quality, no transformation. That's pertaining to the difference variable. Differencing of 1 right here. This is an estimate of the constant and its significance level, and then MA lag 1. So this is the MA1 process, and you can see the estimate was 1, which is actually not a good process that's being captured. And so when we look at the observed quality values plotted against the fitted values, you can see it does a terrible job. Our current ARIMA model does a terrible job of fitting the pattern that was observed in the data. So let's look at another option. So let's run our forecasting we'll go back to create traditional our models again, and under criteria, let's try this without a constant in the model. So in this case, we're just going to remove this. Oh, and by the way, just to kind of show you really quickly, let me kind of go back here. When we generated our residuals, these were the residuals, and so like I said, you could use the ACF and PACFs shown in the parallelograms to kind of evaluate how well the model is doing in picking up the AR or MA processes in the residuals. So I'm going to remove this and go back, forecasting, create traditional models, and so like I said, we're going to remove the constant here. We're going to leave everything else the way it was, and I'm also going to remove the this right here because that was just kind of an FYI in the previous demonstration. So let's run our model, and so again, we still have our 0, 1, 1 model that is being tested, and when you scroll down, you can see that in terms of the significance, it's non-significant. When we look at the process, you can see it still does a pretty crummy job. This current model does a pretty good crummy job of being fitted to the observed data. But when you look at right here, without the constant included, we have the differencing still represented, and then the moving average process, and you can see that that was statistically significant in the model. So that's just kind of a demonstration without the inclusion of the constant being estimated. So let's try their other model, which was a model PDQ process of 1, 1, and 0. So we're going to go to Analyze, Forecasting, Create Traditional Models. Under Criteria, we're going to, you'll have to kind of double click this, and actually we can just type in 1 right here. We'll leave the differencing at 1, and then the moving average process, we want to set this back to 0. So I got to double click on this, hit delete, and then type in a 0 right here, and then hit enter, and so there you go. We'll leave the transformation as it was before, and let's just run the model with and without the constant just to see what happens. So I'll include the constant first right here. So now you can see we have the ARIMA process 110, and when we scroll down, you can see the significance level is actually we have a non-significant model. There's the BIC right there, and scrolling down, you can see that the constant in the model was not significant. The AR lag 1 process, that was there's a significant negative autocorrelation or autoregression component. It's statistically significant. So and then you have the differencing right here, and you can see that it looks like that we're doing a little bit better job in terms of modeling our taking our ARIMA model and fitting it to the observed data. So so there you go. Now let's try one more. We'll try it without the constant being included. And so I'm just going to remove this, click on continue and on OK. And so now you can see we've got, again, it's not statistically significant. And you can see the AR1 process. There's the process is statistically significant with the first order differencing. And, in this particular case, you can see, really doing kind of a similar job in terms of being fitted. And, but, one of the things is that the BIC here for this model is a little bit lower than it is for this model. And, when you're doing model comparisons, what you're looking for is the more favored model is the one that would have the lower BIC. And so in this case, this model does a little bit better job of fitting than the one that actually included our constant. So at any rate, that is sort of a quick overview of some of the options in SPSS. I will say, just as a side note, you also have options under here that you could also use exponential smoothing potentially. or if you were just looking for the best fitting model that you could find using sort of the program defaults, and you didn't care whether you're using ARIMA or exponential smoothing, then you could click on all models, and you know, and then basically you can see right here, this is a smoothing model that was generated, and we're not really going to get into that particular discussion, but that's an option. You know, keep in mind that just because the program has defaults that that can kind of facilitate deciding on a reasonable model. I wouldn't necessarily say that it always identifies the best fitting model. So you do have to keep in mind that you know, anytime you're using program defaults, you're sort of taking the decision making out of your hands and putting it into the hands of the program. So it probably is worth your while to spend some time learning more in depth about how to identify the AR and MA processes. But like I said, you know, if you're just learning how to do this, and you need to carry out some basic ARIMA modeling, then the expert modeler approach can be handy. But I wouldn't necessarily lay all my put all my eggs in that particular basket either. So that concludes this discussion, and I hope you find this review of ARIMA modeling using SPSS handy.